been waiting way too long. Yeah, I've been down here trying to get it. Yeah, I've been waiting way too long.
This is the video for Chapter 10, Section 2, Finding Arc Measures in Circles. So a couple of vocab words here. Central angle is an angle whose vertex is the center of the circle. So remember we said we name a circle based on its center. So this is circle A. The central angle is an angle where this center is the vertex. So for example, I could draw two segments here, and that would form a central angle. So if this is point B and this is point C, then angle BAC is a central angle. And what happens is that angle forms arcs, okay? And so we're going to look at that in the next example. And so I'm going to draw the same angle here. Similar, it's a different circle, obviously, but. So again, we have central angle BAC, and this right here is arc BC, and that is called a minor arc, and we write it like this. Arc BC is a minor arc, and the reason it is a minor arc is because the measure of angle BAC, which is the central angle, is less than 180 degrees. So a minor arc is an arc formed by a central angle that is less than 180 degrees. The major arc is an arc that is greater than 180 degrees, and we use 3 letters to name a major arc. So again, let's call this circle A, B, and C. There's my central angle. Okay, this is the minor arc, BC. The major arc would be this part of the circle. And in order to name that, we would need another point. So I'm going to put point D out here. So this is going to be arc BDC. Notice that we are going to use 3 points to denote that. Because if we call that arc BC, it's very confusing to know what arc we're talking about. So if it is a major arc, you must use 3 points. If it is a minor arc, you use 2 points. So the major arc, again, will be greater than 180 degrees. Now, when we measure these arcs, the measure of the arc is equal to the measure of the central angle that forms the arc. So if the measure of angle BAC is 88 degrees, then that means that arc BC is equal to 88 degrees. So we can measure these arcs in degrees, and that's equal to the measure of the central angle. So what is the measure of arc BDC, the major arc? Well, if we assume that this is, again, the same measure of the central angle, 88 degrees, the way that we find the major arc is, arc BDC, is that we would subtract 88 from 360. Why? Because the sum of the degrees in a circle is 360 degrees. So 360 minus 88 is 272 degrees. So arc BDC is equal to 272 degrees. A semicircle is an arc with endpoints that are the endpoints of the diameter. So if this is circle A, remember the diameter is a chord that goes through the center. So let's call this B and let's call this C. So the diameter is segment BC. Then a semicircle is an arc with those endpoints. So arc BC is a semicircle. And the measure of arc BC is 180 degrees. So if it is a semicircle, you can just use 2 points to name it. Lastly, I just need to make sure you understand the arc addition postulate, which is very similar to the segment addition postulate, the angle addition postulate. Okay, so here are points on the circle. This is circle P. Okay, so this is circle P. And circle P has points A, B, and C on its circle. And so arc AB plus arc BC is going to be equal to arc ABC. Now, why did I use 3 letters there? Because I can tell that arc ABC, which is this, is going to be larger than 180 degrees. Now, I also want to make sure you understand that when you see an arc written like this, ABC, you need to make sure you follow it in the order of the points listed. So arc ABC is different than arc ACB. Okay, those are different things. So arc ACB would be from here all the way around to here. So those are 2 different arcs, so make sure you follow it. That's, again, why it's important to use 3 letters and to use them in the correct order. So the arc addition postulate, again, works very similar to the segment addition or the angle addition postulate. So please be aware of that as you're solving problems.